one participant coming. So my name is Dr. Vanlu Ranhamte, and I'm going to be your host for Introduction to Cloud Computing. So tonight we will talk about cloud computing and what is the current technology. So as we see in the screen, the topic is clear enough, I guess. So it is cloud computing. So let's dive in. So to understand cloud computing, I will talk about the origin and influence and also basic concepts and so on. So let's start. Let's dive in. And if there are any questions in between, then you can always ask me. So first of all, let's dive into understanding of cloud computing. So cloud computing is a computing paradigm that enable access to shared computing resource or resources such as server or storage or maybe web applications or maybe services on the web over the internet, we can say, on an on-demand basis as well. So instead of we having the resources such as server or storage or maybe application or services in our local premise or in our farm, we can use those servers or storage that are provided to clouds. Okay, so clouds computing eliminates the need for local infrastructure ownership. So it saves a lot of money instead of having the infrastructure locally, manpower, and so on. Instead of those, we can just use someone who are providing such through cloud. So it allows user to access resources remotely with scalability, flexibility, and cost efficient. Okay. So secondly, I'll jump into origin and influence of cloud computing. So first, let's talk about the origin of cloud computing. The concept of cloud computing evolved gradually from earlier computing models. So since 1960s, we can say that the time sharing system was introduced. Time sharing system actually was introduced because many peoples were working in a company and they have to share their working times, right? So multiple users shares single mainframe computers. So that's where it starts, the cloud computing. All right. So that's the root, we can say. So we can say that the resource sharing was introduced in 1960s. Then it comes to utilizations of that computing concepts that was proposed by John McCarthy. He suggested that the cloud computing could be delivered like electricity pay-per-use model, right? So we can see from Google how much storage we want. We can pay for that, and then we can use that much storage which we have. So coming to 1990s, the internet was exploding. The expansion of the internet was a rapid fires, right? Since 1990s. So the growth of internet enables remote access to computing resources when there was no internet. So cloud computing was like impossible, right? So when day to day nowadays we have on our handheld like mobile phone, we have very fast internet. So having cloud computing is not such a big deal or not very difficult to access also. So the internet brings the expansion for cloud computing as well, right? So in 2000s, commercial cloud enterprise emerged, like companies such as Google, maybe DigitalOcean, Amazon, and so on. So company began to offer cloud service such as for storing, for web hosting, applications such as Google Document, Google Spreadsheet, emailing system, and many more, right? So there are many more lists. So let's talk about what technologies influence that cloud computing. So cloud computing is not a standalone invention. It is a result of multiple technologies keeping somewhere a service, somewhere a storage, somewhere a server resource, and so on, right? So first, let me discuss virtualization. So virtualization is the core technology of cloud computing, in fact. So the virtualization enables multiple virtual machines, VM, on single physical machine. Like a big or a good computing servers can act as maybe hundreds of machines using the virtualization. So the virtualization improves resource utilization and also isolation as well. Secondly, we have to think about the distributed computing. So processing tasks are distributed across multiple systems, right? So the distributed computing enhance performance and fault tolerance as well. So third, we can discuss about grid computing, right? So grid computing combines geographically the distributed resources to solve large-scale problem. So prosecutors to cloud resource pooling and so on can be an example. So the distributed resource has been combined together, right? So fourthly, sorry, I went to somewhere else. So let me continue. Fourthly, we have utility computing. So introduce the utilities computing introduce the pay-as-you-go model, like in Google Cloud Compute, Google Map resource. So when a developer or maybe an enterprise use the Google Map SDK, they can go as you pay. The more they use, the more they pay. All right. So the less they use, less amount they have to pay as maybe end of the month, right? So utility computing introduce users to pay only for the resource they consume. All right. So if we use very less amount of server resource, so we pay less, and so on, right? So fifthly, I want to talk about the web technologies, particularly from Web 2.0. Now we are in Web 2.0, obviously, and then for uncentralized system, we can say that's Web 3.0. So for web technologies, Web 2.0, in fact, enabled interactive scalability and user-driven applications such as Facebook, Instagram are used for advertising platforms and many more, right? So the web technologies facilitated the cloud-based performance and services as well. So we have to talk about the high-speed internet as well. So the high-speed internet is the actual backbones of the cloud computing nowadays. So the high-speed internet enables real-time access and data transfer, right? So that's also play very important. So what are the things we have to consider for the cloud computing technologies, or the technologies that influence cloud computing? First was virtualization, second, distributed computing, third, grid computing, fourth, utility computing, fifth, web technology, Web 2.0, Web 3.3, and so on. 3.0, and high internet speed, right? So let's dive into the basic concept now. So basic concept of cloud computing, all right? So cloud computing is defined by several core principles. So let me first discuss the on-demand self-service. That time I talk about on-demand, right? So pay as you go and so on. So user can the provisions for cloud computing resource automatically be selected without any human interaction, right? So if the SDK for Google Map was used by the developer more, they have to pay more bills, right? So the user don't have to set the limits as well, right? So pay as you go is something like that. So the on-demand self-service is the one of the features or basic concepts of the cloud computing. So secondly, we have broad network access, right? So the broad network services are accessible over the internet via various devices, right? Such as laptop, mobile phone, TV, CCTV, and so on, right? And the accessibility is very broad for cloud computing. So thirdly, we have resource pooling. So provider resources are shared among the multiple users, such as if I have 128 GB RAM on the server, And if one user needs only 2 GB, only 2 GB will be allotted to that particular user, and the other want 4 GB, and so on. So let's say for those two users, we use in total 6 GB. That means from 128, 122 is still available, right? We're talking about RAM. So that's how the resource poolings are done. So fourthly, I want to talk about the rapid elasticity. So resources can be scaled or modified or custom, right? Resources can be scaled up and down. In fact, up and down quickly based on the user demands, okay? So fifthly, measured service, like the usage is monitored and billed based on consumption. So this can be done in AWS services. So the AWS Amazon Web Services provide many things which we can metered or maybe measured on. So as per that, what we have defined, as per that, the service will be served. So let's talk about the service model now. The service model, fundamental concept of service model. So we might have heard about SaaS, PaaS, ES, all right? So IaaS. So that infrastructure as a service, infrastructure as a service provide basic infrastructure such as virtual machine, storage, networking, and user control OS and application, right? So PaaS, that's a platform as a service. So platform as a service provides platform for development and deployment. Developer focus on coding without managing hardware, right? So they use the hardware from somewhere else, the servers, all right? So almost similar to the infrastructure as a service, all right? So thirdly, we can talk about the SaaS. SaaS is software as a service. So later on, I'll talk all these three concepts again. So SaaS provides software application over the internet, no installation required. We can access those services using web browser, okay? So such as Google Forms, in simple terms, layman. So we can also access Google Spreadsheet, Google Presentation, and so on, right? So there are many more applications out there. So before I go to the next slide, let me just talk about the deployment models as well. So public clouds are there, private clouds are there, hybrid that combine public and private together is there. And also we have a community cloud, okay? Public clouds are available to general public over internet, all right? So that are managed by third-party providers, obviously. So private clouds are dedicated to a single organization, maybe your college. So your college only can access that cloud and so on, right? So maybe the private clouds offer higher security and controls as well compared to the public, or free clouds are also there, right? So thirdly, we was talking about hybrid cloud, right? So hybrid cloud is a combination of public and private cloud. So it enables flexibility and data sharing, all right? So community clouds, on the other hand, is cloud or resources shared by organizations with similar requirement, all right? So we have done a lot. So what are the terminology in that cloud computing? First, we need to see cloud providers, the organization that offer cloud service, and data center, physical facilities that host things, stuff, web files or documents and so on the cloud infrastructure. Thirdly is a virtual machine or VM in short. So it's a software-based emulation of physical computers, all right? So fourthly, scalability. So the ability to increase, decrease the resources as per the user needs, all right? So elasticity, that also comes as a scalability, but elasticity is something like automatic scaling based on the workload. If high internet traffic comes in, then the workload also increases, right? So that type of service elasticity also may be there for cloud computing, right? So next is the sixth is latency as well. So there is a time delay in data transmission also, right? So data balancing and all this stuff also will be important. So we'll be talking about all this stuff later on. And also we have to consider the bandwidth, the capacity of data transfer over the network. So if a server can serve only for 1,000 parallel connection, but at the same time, maybe 7,000 users try to access the server. In that case, if the bandwidth is limit, then that's going to be a very bad service, right? So we have to see the multi-tenancy as well. And API, you might have heard about application programming interface, right? So it allows the communication between the cloud service and some other applications, offline, local, or private network as well. So we will talk about all this stuff. So let's dive into the next slide. So here, in cloud computing, what are the goals and benefits? Also, what are the risks? We'll be talking about such. So first, let me dive into the goal of cloud computing, what goals we have. So as we can see in the screen, first, cost efficiency, very important, right? So cloud computing actually is designed to achieve the following strategies. So let me discuss them one by one. So cost efficient and reduce capital expenditure, right? So reduce capital expenditure, sometimes called CapEx, on hardware and infrastructure instead of having on your own. Let's say maybe your neighbors also want, and maybe the neighbor of that also wants, and everyone having in the local may be very, very much costly. Instead of that, if cloud computing was used, that bring the cost efficiency, right? So the shift to operational expenditure, OpEx, in short, models brings the pay only for actual resource use, bring the cost efficiency, right? So secondly, scalability and flexibility, right? So dynamically scaling the resource up or down based on the user demands. Also, supporting variables workloads without performance degradation. So that's the scalability and flexibility, all right? Third, we have high availability and reliability. So the cloud computing ensures services are available 24/7 with minimal downtime, all right? So the use redundancy and distributed data centers are also one of the features that brings to the reliability, right? So fourthly, we have resource optimization. So efficient utilization of computing resource through virtualization. We already talked about this. And also avoiding the underutilization and over provisions, all right? So fifth, we can have accessibility and mobility, right? So access services from any location and device, support remote works and goal collaboration as well. And also we can also have rapid deployment, right? Faster provisioning of the infrastructure and application. And also cloud computing reduce time to market, as we say. Time to market is means rapid development, right? So the cloud computing reduce the time to market for software solution as well, right? So that's very important point. And lastly, not the least, innovation and enablement. So the cloud computing aims to provide platforms for AI. It's very popular nowadays, big data, IoTs, and analytics, right? So it's also encourage experimentations and also development. Maybe you have already known about the LSI development, software development lifecycle, and so on, right? So many things are there. So now let's move on to the benefits. So what are the benefits of using cloud computing? First, we have already talked about economic benefits, right? That time we talk about the expenditure reduction and so on. So lower infrastructure and maintenance costs. First of all, we can say that economics under that economics benefits. So there is no need of having physical hardware investment that to be kept in the local, right? And also it reduced IT staffing requirement. So in cloud computing, you are alone, right? You can manage everything. There is no need to hire anyone to look after the server or for networking or maybe for the power, electricity, and so on, many things. So those things are all taken care of by the cloud computing providers, all right? So secondly, we can see the scalability. That's automatic resource scaling based on the workload, and also it's very much ideal for startup and growing organization as well. So I already talked about the scaling up and down and so on. So I think we are already clear with this. So third, we can see the performance. All right. So high speed processing using powerful cloud servers. Also, sometimes you might heard the content delivery network, CDNs. So all these are based on the cloud computing. All right. So the reliability and backup also I already talked a little bit. So we can move on. So to the risks of using the cloud computing. So it has lots of advantages already, right? We talk about all the advantages. Now let's talk about the drawback. So it has some several risks, right? First of all, data security risks. So sensitive data stored on the third-party server may be leaked by the organization or maybe some other users or staffs, right? That's very risky. And also risks of data breach and cyber attack as well, right? So secondly, privacy issue. Data may be stored in different geographical location, but if we do not comply with data protection law, that may be a challenging. All right. So the privacy issue also comes in. Now, the third is vendor lock-in. So if we want to migrate to different cloud providers or something like that, if they lock our data, what should we do? So sometimes that can happen, right? Depend on the proper proprietary tools and service they are using. Maybe the data, our data were locked in their server, therefore we cannot migrate it. For example, mega.co.nz, and they encrypt all our data with that encryption key, even though we can access it so easily directly from this server, we cannot migrate it to another server, right? So that's the thing, that's the play, right? So next, fourth point, maybe data loss. So there's a risk of accidental deletion or system failures that's out of our control, and also there may be a severe consequence as well, right? So lots of things are there, and as I said, insider threat, unauthorized access by employee of the cloud providers, those things also can happen, right? So what are the challenges we have actually? So the first challenge we have is internet dependency. Without internet, we cannot access the cloud computing, right? So it requires stable and high-speed internet connectivity. So poor connectivity affects the performance and accessibility of the cloud computing resources, right? So secondly, we have a downtime. Excuse me. Secondly, we have a downtime service outage. So cloud provider may experience outage that can impact the business operation, right? So the downtime and service outage can be the risks. All right. So next we have security measures. So sharing the resources, sharing the storage, and all the stuff can bring the security measures to risks, right? So user secure data application may be compromised and so on. So there are many things to be discussed. Okay. So fourthly, we have compliance and legal issues. So we must adhere to the regulation or data protection, industry standard, and so on, cross-border data transfer issue, and so on. All those stuff have to be taken care if we are using the cloud computing. So even if I am here in India, if I have to store my data to Europe server, then I have to comply with the Europe data privacy or legal issues. So I have to comply with those, right? So there are lots of limitations there. So third is limitation control. User always have less control over infrastructure in cloud computing. So the dependence on providers' policies and configuration sometimes limit our control, right? So in the sixth point, we can have performance variability. Sharing resources in the server may lead to inconsistent performance, right? So the latency issues due to the geographical distance also can happen. Suppose if the server where I take the cloud computing is from US and I'm from India, in that case, maybe whenever I try to access or my customer try to access my application, in that case, maybe there are some kind of a delay or performance variability maybe there, right? So as I said, migration challenges are there always in cloud computing, right? So those things we have to take in care. All right. So In the next slide, we'll talk about the fundamental concept of cloud computing, fundamental cloud characteristic, right? So cloud computing operates on a service-oriented and layer architectures, all right? And cloud computing, where different stakeholders interact within clearly defined roles and responsibility, right? So secondly, we can have our roles and boundary in a cloud computing. So cloud computing environments follow a multi-actor model. Remember that multi-actor model where each entity has specific responsibility. So here we can have a subpoint such as cloud providers. Who are the cloud providers? The organization that delivers cloud service, such as infrastructure or maybe platforms or maybe software. They are the cloud provider, all right? So they are responsible for data centers and hardware, network infrastructure as well, right? Service availability and uptime and so on, and also maybe physical security as well. So they have to take care of those. So next point, we have cloud consumers, the users, right? So individuals or organization using the cloud services are the cloud consumers or users. The users are responsible for the application uses and also data management, access control, such as user permission and so on, right? So third, we have a cloud broker. They are like a person acting intermediary between providers and the consumer, right? Like as resellers and so on. So what are their functions? They have to take care of the service aggregation, service integration, cost optimization, and so on, right? So fourthly, we have a cloud auditor. So that cloud auditor is an independent entity that evaluates cloud service. They ensure security compliance, performance standards, regulatory adherence, right? So fifth, we have cloud carrier. So cloud carriers provides network connectivity between providers and customer, right? Typically, they are the ISP, such as Airtel, BSNL, and so on, right? Telecom companies, we can say. So what are the boundaries? All right, you may ask. So cloud computing operates under a shared responsibility model. From the cloud provider side, they have their own roles. From the user side, they have their own roles and so on, right? So that defining the boundaries between the providers and the consumers. So provider responsibility, what are the provider responsibility that time I talk about? So they have to see for the physical infrastructure, such as server storage and networking, right? Data center security, virtualization layers, service uptime and maintenance and so on, right? So what are the customer responsibility? Data security and privacy, application configuration, user controls, compliance with policies, right? So there are many more things. So I'll jump into resource pooling. So what is the resource pooling? Provider resources are pool. Pool means sharing, right? To serve multiple users based on the multi-tenancy model, all right? So we may say about the rapid elasticity where the resources are increased, means up and down, like we increase the capacity, we decrease the capacity and so on, right? Appears to be unlimited to the users, right? So many things are there, that elasticity things are there. So resources are pooled, all right? So that measurements have to be there. So I think we already know about this. So I have discussed it. So let's move on to the next content. So that time I discussed about the cloud delivery method. So many times if we visit or if we develop a web application, then we may have seen the CDN, content delivery network, all right? So before I discuss that, what is that cloud delivery method we have? What are the things we have? We have SaaS, right? Software, as we can see in the screen, software as a service, right? So also we have a PaaS, platform as a service, and infrastructure as a service, all right? So we are going to discuss all this level of control, flexibility, and management responsibility, all right? So first, let me dive into the infrastructure as a service. So infrastructure as a service, or IaaS, in short, provides basic computing infrastructure such as virtual machine, all right, storage, network, Fine. So users can install and manage their own operating system. Anything they can choose, maybe Ubuntu or Windows or maybe Fedora and so on, and also the applications they like. So that was infrastructure as a service, right? So what are the key features we have there for infrastructure as a service? The user have a full control over the OS, all right, and the application. So the scalability infrastructure that means very high, right? So the users are usually going with pay as you go pricing or else on-demand resource provision, all right? So what are the responsibilities for the providers? They have the cloud computing providers in terms of the infrastructure as a service have to provide the hardware, networking, and virtualization. And what are the responsibility for the users? They have to install the OS, right? They have to choose the OS, the middleware, the applications, whatever they want to use on that server and the data. All right. So what are the use case? So if I want to host a website, then I can go for that. All right. So if I want to store data, backup, restore, and so on, or sometime if I want to test my application, use it as a development environment, I can go with the infrastructure as a service, right? So secondly, we have platform as a service, PaaS in short. PaaS provides a platform and environment for application development without managing the underlying infrastructure. Forget about the infrastructure as a service. So we will be using the platforms, right? So the key features can be, it is already pre-configured development environment, all right? So it supports multiple programming language, built-in tools for development and deployment, all right? Automatically being scaled. So talking about the responsibilities, the cloud providers are responsible to provide the infrastructure, the OS, the runtime environment, all right? And the users is responsible to only go for application code and data, all right? So what are the use case? So for developing web or mobile application, okay? And also to develop the API, all right? API development and also for testing software and deployment. All right, so let's jump into SaaS. That's a software as a service. So in short, right, SaaS. So SaaS deliver ready-to-use software application over the internet. For example, Google Docs, Google Spreadsheet, Google Presentation. I use those example, right? So users access those applications through web browser. All right, there is no need to do any kind of installation. They just have to access the software using web browser. All right, so no installation is required. We can access the application from any device, maybe laptop, maybe mobile phone. All right, so most of the SaaS are subscription-based model. All right, and updates are also automatic. Once it is updated in the server, we access it with using browser. That means automatically updated, right? So what are the responsibility? The cloud providers or the SaaS provider provide everything, infrastructure to application, everything, and the user only use and minimal configuration need to be done by the users, right? So use case such as email service, online office tools, as I said, Google Docs, Google Spreadsheet, and so on, and CRM, you might have heard, customer relationship management. So for those, this use. Now, let's compare briefly these three things, the features of infrastructure as a service, platform as a service, and software as a service, right? So it's quite simple, right? So we have the control, high, medium, low flexibility, and so on, right? So in PaaS, the control is high. Sorry, in infrastructure, the control is high. In platform, the control is medium. And in SaaS, the control is low. We already discussed this just now, right? So if we see the layer view, if we want to see as a layer view, then we can see as is infrastructure layer is the IaaS. All right. So the platform layer can be platform as a service, and application layer is a software as a service. All right. So does it have limitation? Yes, obviously. We talk about all the advantages. Now let's see the limitation. less control on the higher level, SaaS, less control, right? Vendor dependency, security concern depending on the models as well, right? So there are many things that we can discuss. So let me jump to the cloud deployment method. So cloud deployment models actually define where and how cloud infrastructure is deployed and who has access to it. All right. They determine the ownership, accessibility, security level, control over resources, right? So there are 4 primary deployment methods or models. So the deployment models are, first is public cloud. Second is private cloud. Third is hybrid cloud. That's combined public and private clouds, right? Fourth was the community cloud. All right. The community cloud is a little bit different compared to that, right? So let's move on. What is that public cloud actually? A public cloud is a cloud environment where services are provided over the internet to multiple users, multi-tenant, we can say, right? So it is open to general public. All right, it is owned and managed by the cloud providers and shared infrastructure, such as they also provide pay-as-you-go pricing, right? And also the advantages of the public clouds are low cost and high scalability, easy access and deployment. All right, limitations are obviously there, so there are less control over data. So security concerns are there, privacy concerns are there. All right, performance variability are also there. So the use cases where if we want to have a web application, then obviously we have to go for public clouds, right? And startup business and small business use mostly public cloud, and testing and deployment can go for publics, right? So next is private cloud. So private cloud is a cloud infrastructure that is dedicated to a small organization or a single organization, I should say. So it must be something like on the premise, or maybe on the campus, or maybe within the organization itself. And it may be provided by third-party providers as well, right? So it's exclusive access. It provides only exclusive access. So the security compared to the public cloud security is high, and control is also higher, right? So it can be customized environment. So what are the advantages of having private clouds then? So enhanced data security, greater controls over resources, right? Compliance with resources. And obviously, when we have advantages, we always have on the side the limitations, right? So it's a high cost because they have to have their own infrastructure. Otherwise, it have to be dedicated purely for the organization. And it requires maintenance expert also, manpower, right? So limited scalability compared to public clouds, all right? So what are the use cases? Government organization, such as state-wide area network, same thing, right? Banking and finance system, they have to use that. Healthcare system may use, all right? So next is the combination of the two, the public and private. So that's a hybrid cloud. So a hybrid cloud combines public and private clouds environment, all right? That allows data and application to be shared between them, between public and private clouds, all right? So the characteristic can be integration of multiple environments, data portability, flexibility in workload management, and so on, right? So we can have best of both worlds, right? Security plus scalability, that's the advantages. Cost optimization comes in as well as the advantages. And also we have flexibility in the deployment, all right? So what can be the limitations? Complex architecture, because we combine two clouds, private and public, right? So it requires proper education and management. Security configuration have to be done properly, so that challenges happens, right? So e-commerce, disaster recovery system, and so on use these hybrid clouds, all right? So what about the community clouds? Community clouds actually is shared by multiple organizations with similar requirement, such as security, maybe compliance or missions, all right? So share infrastructure among specific groups is very much in layman terms, all right? So the the community clouds managed internally by the or maybe by the third party as well. So it has codes share amongst the members, right? So limitation comes as a scalability. The controls may have the users or organization may have a conflict in the controls, so that comes under the limitation. All right. So the use case again comes to research institution, educational organizations, government departments, and so on, right? So they may use this type of model. So if we go in the next slide, we can see cloud enabling technologies. All right. So cloud computing is not a single technology, as we already seen in the previous slide. It is an integration of multiple foundational technologies. All right. So that's together enable the scalability, on demand, and remote computing services. All right. So let's talk about the 5 things here. First, I'll talk about the broadband network. All right. So broadband and internet architecture, we can say. So broadband network refers to the high-speed internet connectivity, all right, that allows large volumes of data to be transmitted quickly. All right, I think it is clear. Okay, so without broadband, cloud computing would not be practical. I had mentioned it, right? So when you access Google Drive or any cloud application, data is constantly transferred between your device and the remote server. So high bandwidth ensures smooth performance, while low latency ensures quick response time. All right. The lower latency you have, the quicker response you get. Right. So secondly, internet architecture. The internet follows a layers of architecture. We know that, right? Enabling communication between devices globally. So there's client layers, network layers, server layers. All right. So I'll try to keep it in simple. So what's there in the client's layer? In the client's layer, there are user device, all right, such as laptop, mobile, maybe your TV, and so on. Those are client's layer, all right? So what about the network layer? In the network layer, we have routers and communications links, all right? So here, maybe ISP also comes in, all right? So third, we have a server layer. In the server layer, we have cloud servers, data centers, platforms for platforms, and so on. All right. So we also can say that when a user requests a cloud service, a request is sent from the client, right, using web browser. You are opening web browser and then you send the request, right? So it routed through the network's infrastructure. Then it reached the center where you want to take the service from. All right, that's the data center, maybe the infrastructure itself. So process it in cloud data center, and response is returned to you, the user, right? So what are the concepts we can see from here? You might have seen TCP/IP layers, right? TCP/IP, we already know, enables reliable communication. So if any packet is missing in between, that packet will be resent again, right? So that's a TCP concept. So TCP/IP, we all know, right? So DNS, it converts the domain name which you type in your web browser into IP addresses, right? So latency, I have said that the lower latency you have, faster response. So latency is the delay in communication, all right? So next is bandwidth. Bandwidth is the data transfer capacity, how much data you can fit it in one go, right? So maybe in 1 millisecond, you can transfer up to 700 KB packets. So that's the bandwidth, right? Okay, so second thing is data center technology. So what is data center technology? A data center is a centralized physical facility where cloud providers store and manage computing resource. All right. So data centers are the physical backbones of the cloud. Even though cloud seems virtual, all data is actually stored in real server location on all these centers. All right. So here what we need to know first is the server. What is server? Server is a server perform that computation, right? And storage system store user data. All right. And third is network equipment that enables communication. All right. And also we need to know that there's a cooling system. So the cooling system prevent overheating. All right, in the data center technology. The cooling system is very important. That's why Elon Musk want to construct data center in the space. I think you have heard that news. All right. So most importantly, even if the power goes off, the backup should be there. So power backup is very much required. So the data center ensure uninterrupted service by having power backup. All right. So why it is important? Backup system to prevent failures. All right. Service remain accessible 24/7 and data recovery in case of failures as well. All right. So third, let's jump into the third point. That's a virtualization. So virtualization technology. All right. So virtualization create virtual version of physical resources, and it allow multiple systems to run on single hardware unit. So that's the virtualization technology. All right. And also, instead of one physical server for one application, virtualization allows one server, multiple virtual machines. One server to be multiple virtual machines. All right. It's virtual machine as independent computers. This is the core technology behind cloud computing. All right. Remember that. And what's the role of supervisor, hypervisor? I mean, software that manage virtual machines are called what? Hypervisor. All right. So it allocates CPU, memory, and storage. All right. Okay. I hope you are clear. So we'll go to the next point. That's a web technology. All right. Web services technology. So web technology enables user to access cloud service through browser and web application, right? So cloud services are mostly delivered via the web. For example, when you want to access Gmail, how do you access? Through browser, right? When you want to access Google Docs, how do you access? Browser. So do you need to install? No, you don't need, right? So that's the web technology, all right? So what are the technologies you use there? HTTP, HTTPS, Hypertext Transfer Protocol. I think you have heard about this. This is a communication protocol that is a must to use, right? Second thing, we have the web server that handles the request. Whatever request you send, it will handle, right? Third is browser. The user should be able to interact with what request is sent and what response is received. He should get it in the form of something, some presentation form, right? So the web browser comes there. All right. So, okay, last not the least, we'll discuss about multi-tenant technology now. So multi-tenancy allow multiple user, we can say them as a tenants, all right, to share the same infrastructure while keeping their data isolated. All right. Think of it like an apartment building, same building, right? The same building as is an infrastructure. Different apartment in the same building, different apartments are the users, and each user's data is private. All right. So what's the advantages of multi-tenancy technology? It's cost efficient, efficient resource usage, and scalability. All right. So it comes as a challenges. We can have data security and isolation, and also performance sharing among user also comes as a challenge. All right. So there are things you need to know about software-oriented architectures and microservice architectures, API that allows communication between service essential for integration, and also web services that use REST or SOAP protocol to interact between platforms, like from one server to another server, right? So those things you can have a look further. So time is almost up, but I try to complete the discussion on the fundamental cloud security. All right. So cloud security refers to the sets of policies, technologies, and controls designed to protect data, applications, infrastructure in the cloud environment. Simple as that. Since cloud data is stored on remote server and accessed via the internet, it becomes more exposed by cyber risks. All right. Therefore, strong security mechanisms are essential for cloud technology, right? And what are the basic terms, right? Let's discuss about the basic terms. So ensuring data is accessible only to the authorized user, the confidentiality have to be maintained. Techniques like encryption and authentication prevent unauthorized access, right? Second is integrity, right? So the integrity ensures that data is accurate and not altered. So mechanism like hashing and checksum verifies that data has not been tampered with. All right. Thirdly, availability. So the availability ensures that system and data are accessible when needed. Archive through redundancy, backup, and fault tolerance system. Right. So fourth is authenticity. So process of verifying the identity of a user. How? Using password, using biometrics, right? And even OTP also uses authentication, right? So next is authorization. So authorization determines what an authenticated user is allowed to access or to perform onto that system, right? And sixth, we have encryption. So encryption converts data into unreadable form, right? Unreadable form from preventing unauthorized access. Fine. So threat agents are entities that can cause harm to cloud system. So all these have to be ensured, right? So identity and access management, IAM. And next is multi-factor authentication that maybe require multiple verification method for access. Only OTP is not enough. Maybe some other things also have to be included. And also rules and procedure have to be followed. So security policies. All right. So have to be taken care of all this stuff, right? Next, we have cloud infrastructure mechanism. So cloud infrastructure mechanism are technique components and control that enables and operate management and security of cloud environment. All right. So there are things you have to take care on this. And if you have any question, you can ask. Thank you.